Hi, Michelle Glass here. Welcome back to our third episode of our lecture 23, chapter 23, and we are still working through that pulmonary ventilation information. And our topic for this video is respiratory volume. So let's get started. Now, when we are doing our normal resting breath, we're going to describe that as our tidal volume. Now notice tidal volume can be abbreviated as big V subscript capital T. This is essentially the amount of air that is moved in one respiratory cycle. So that's just your regular, normal, resting, quiet inhale and exhale. Now remember that our quiet breathing is being controlled by the contraction of the diaphragm and the external intercostals. When these muscles contract, that's going to increase the volume of our lungs, which is going to decrease the pressure, so air is going to get pulled in. And then as those muscles relax, then our rib cage falls back into place. The lung is compressed to some extent, so you decrease your volume, increase your pressure, and air is pushed out. So remember, our passive exhale is from the relaxation of the diaphragm and the external intercostals. We can actually calculate our respiratory minute volume. So this is abbreviated big V subscript E, and this is your breaths per minute, so your respiratory rate, times your tidal volume. So if we are taking 12 breaths per minute and our tidal volume is 500 milliliters of gas, then in 1 minute you're exchanging 6,000 milliliters or 6 liters of air with your environment. So that's what that means. Now, if we need to increase our respiratory minute volume, then we can either increase our tidal volume, so let those resting breaths be a little bit deeper, or we can increase our respiratory rate, or you can do both. So in order to increase your respiratory minute volume, you can increase one or the other or both. Now that is going to be true for the pulmonary ventilation. That's really what we're calculating and measuring here with the respiratory minute volume. We have actually another type of ventilation which is described as alveolar ventilation. Your alveoli, remember, are your locations for gas exchange. The alveolar ventilation is abbreviated as VA, and this is going to actually be a smaller amount of air getting into the alveoli compared with the amount of air that's actually getting into the lungs. So your alveolar ventilation is less than your pulmonary ventilation. And the reason is because about 30% of your inhaled air never reaches that respiratory portion. So as you're inhaling in, your remaining 30% of that total air that was inhaled remains in that anatomic dead space. The anatomic dead space, remember, is the conducting portion. So that's that network of trachea and bronchi and bronchioles that are not involved in gas exchange. So you always are going to have some old air in that area. So the air that reaches the alveoli has less oxygen and more carbon dioxide compared to the atmosphere. So this is interesting. The other reason that this is interesting is in order to increase your alveolar ventilation, you have to increase both your tidal volume and your respiratory rate. So if you're not getting good oxygen to your alveoli, then you're going to see deeper breathing, and an increase in the respiratory rate is required in order to get adequate oxygen to the alveoli. So how much air can your lungs actually move? Well, we've already talked about our tidal volume as our resting or quiet breath. So that's the type of breathing that I'm doing right now. You don't really hear it. We don't see it. I'm not thinking about it, except now I'm talking about it, right? And then we have what's called our inspiratory reserve volume. Remember, inspiratory is talking about our inhale, and we saw that we have accessory inspiratory muscles that are going to help really expand our thoracic cage. So I can do an experiment where I take a quiet inhale with my nose, hold it at the top, and then breathe in more air. So let's do that together. So do a quiet inhale, hold it, and then Inhale more. That amount of air that you could inhale more was your inspiratory reserve volume, or your IRV. Okay, so this is your forced inhale. So collectively, your quiet inhale plus your inspiratory reserve volume makes up your inspiratory capacity. So if I do one long, how much air can I suck in through my nose? That is my inspiratory capacity. We can have the same conversation about our exhales. So we know that we have a quiet exhale, part of our tidal volume, the relaxation of the diaphragm and the external intercostals. We also know that we could force out more air, right? And so you're recruiting more muscles from your thoracic cage and muscles from your abdominal cavity to really pull down on that thoracic cage, compressing your lungs, pushing that air out. That forced exhale is your expiratory reserve volume. So I can do my quiet exhale, stop, and then exhale some more. So you can do that with me. You can maybe do exhale through your nose. It's really more fun to do it through your mouth. So take a big breath in, and then so I exhaled my tidal exhale plus I exhaled my expiratory reserve volume, but I didn't empty my lung at all. I still have air in my lung. That air in my lung is called my residual volume. It's that old air that's always there. So remember, when we're inhaling our air and 30% remains, it's mixing in with that old residual air. So that's why we have less oxygen and more carbon dioxide gas reaching our alveoli compared with the atmosphere. Now, your residual volume also includes what's called your minimal volume. This is air that's staying in your lungs. Even if your lungs collapse and all of this air gets forced out, you still have some air that's remaining in your lungs. Collectively, then, we can call all of this air functional residual capacity, because we're not usually walking around going, right? We're usually doing our quiet tidal volume. So usually all of that extra air that you can force out in that expiratory reserve volume is in your lungs, as well as all of that residual volume of air. And so again, that's why as we take those inhales and some of that air stays and mixes with that old air, we're getting less oxygen to the alveoli. So all of this air that's usually in the lung there is called your functional residual capacity. Your vital capacity is the total amount of air that you can move by your lungs. So if you go, that's your vital capacity. So that's including tidal volume plus IRV, inspiratory reserve volume, plus ERV, expiratory reserve volume. The total lung capacity is including how much air can your lung actually hold. So that means how much air you're moving, your vital capacity, plus that residual volume that you're not exhaling out. That's your total lung capacity. Okay, and that's it for now. Stay tuned.